dot product is a fundamental way we can combine two vectors, and intuitively, so you have an idea of what the dot product does or what it tells us. The dot product tells us of how much two vectors are in the same direction or point in the same direction. This is what you're given in the FE handbook on dot product and on vectors, actually. And here you're giving the formula for the dot product. So A dot B equals to AX BX, and I will just, take another vector, B. I want to make it more clear, and B is Z. Okay. It's a little bit messy, but just want to make my point here that dot product has this formula where you multiply the corresponding components. So the X components, Y components, and if you have more Z and more components, the corresponding one. So AX BX plus AY BY plus AZ times BZ. At the same time, dot product has this formula where you multiply the magnitude of A times magnitude of B times cosine of theta, and theta is the angle between the two vectors. Another thing that FE handbook is giving you is that dot product is commutative, meaning that A dot B equals to B dot A. Here you're told that the dot product is a scalar product and represents the projection of B onto A times magnitude of A. And this statement here, really, it's very important. We will have an example and we will explain exactly what it means. And here the dot product is a scalar product. Also, it's a very important statement, and I'll have an example about that. So now let's go ahead and start. Problem number 1, what is the result of a dot product? So what do you get when you have vector A dot vector B? If you don't know, let's say you have no clue what it is, I'll suggest you take two vectors. I'll just assume vector A has the components 1, and vector B is equal to, I'll say, 0 minus 1. And then I'll use the formula where I'm going to multiply the corresponding components. So I'll do A dot B equals to 2 times 0 plus 1 times minus 1. And I'll get that A dot B equals to minus 1. So what is the result of a dot product? It is a number, right? You get a real number. The result is always a number. So it is not a vector. It is not a resultant. It is not a moment. It is a real number. It's a number. And another word for the number is a scalar. And as I said, you are told that in the FE handbook. And it's very important to understand that the dot product is a scalar product. What they mean by the dot product is a scalar product is that the dot product of two vectors is a number or is a scalar. So the correct answer is A. Problem number 2. What is the dot product between vector A and B? And the options here we have 0, it is positive, it's negative, or D, not enough information to answer this question. So remember at the beginning, we were given this information that the dot product, intuitively, it tells us something about the point of orientation of the two vectors. So how can we figure this out? I will write the formula down. A dot B is equal to magnitude of A times magnitude of B times cosine, and I don't want to put this. This is the regular multiplication, cosine of theta, and this is completely different. Make this bigger. This is not just regular multiplication. This is the dot product, has different properties. This is regular multiplication, and usually I just don't add it. So this is the formula for the dot product. Magnitude of A, magnitude of B times cosine of theta, which is the angle between the two vectors. So again, we don't have any information on the vector, but we know that the magnitude, the way we calculate the magnitude, I can actually assume that, let's say, I'll just assume that the magnitude of A, let's say I'm going to assume it's equal to 3, and I'm going to assume the magnitude of B equals to 4. And we know that magnitude of any vector is always positive because we take square root of the sum of the squares. Anyway, to make it even more, intuitive, I can give values to, I can just take a vector, but I think this is enough, just taking the magnitudes. So let's see how can we, moving forward, can explain or can answer this problem. So let's say if theta equals to 0, right? In other words, when you have vector A when vector A is collinear in the same direction with vector B, and I'll make this vectors, right? The angle between them is 0. What are we going to get? We're going to get that, actually, let me just say, what does that mean? What does that mean? That means that cosine of theta of z equals to cosine of 0 equals to 1, right? So this means that A dot B is equal to the magnitude of A, which is 3, times magnitude of 4, which is 4, and times cosine of 0, which is 1. So I'll get 3 times 4, 12. And now let's do what if theta equals to 90 degrees. In other words, if our vectors, we have this, our vector B, and this is vector A, and the angle between them is 90. So what happens is cosine of 90 is going to be equal to 0, as we all know. So what it means that the dot product is going to be equal to 3 times 4 times 0, and it's going to be equal to 0. Let's go even farther. So now we went from the angle being 0, we went to 90 degrees, and I'm going to go all the way and have the angle as 180, and let's see what happens. So if theta equals to 180, so that's when we have the vector A pointing this direction or direction, and vector B pointing in this direction. That means that cosine of 180 is equal to minus 1. So from here, it results that A dot B is going to be equal to 3 times 4 times minus 1, and we're going to get minus 12. So what I want to focus here is for you to understand is that when the angle between the two vectors is 0, that's when you're going to get the maximum value for the dot product. You're getting 12. And then when the angle between them is 90, you're going to get the dot product. It's going to be equal to 0. So which means that we're starting from the maximum value when the angle is 0. And as we go to 90 degree, the value for the dot product decreases from the max, right? From the max value, it decreases all the way to 0. And then what happens from 90 degree all the way to 180, it gets to, this is the minimum value, I should say, right? So here from 0, it starts decreasing to the minimum value. So here you're going to have positive values, and here you're going to have 0 at 90 degrees, and from 90 to 180, you're going to have negative values. Another way this can be explained, I'll say, if theta, if angle between the two vectors is less than 90, is an acute angle, then we have a positive value. When angle theta is equal to 90 degrees, dot product is equal to 0. And when the angle theta is greater than 90 degrees, or you have an obtuse angle between them, then we get a negative result, as we could see here. So just like that, we can figure out if the dot product between two vectors is positive, is negative, or is 0. So in our case, we have vector A and vector B, and the angle between them, it's clearly an obtuse angle, right? It's greater than 90 degrees, so it's pretty simple here to answer. The dot product is going to be negative. Problem number 3. Which statement is true about these two vectors? A equals to 3i plus 4j minus 8k, and B equals to 4i minus 7j minus 2k. A vectors are parallel, B vectors are perpendicular, C, the angle between the vectors is 21.4 degrees, D, both vectors pass through the point 1, minus 1. This is another example where we're going to use dot product to solve this problem. She's going to take A dot B. It's going to be equal to magnitude of A times magnitude of B times cosine of the angle between them. Also, we know that dot product can be also written, another formula is ax bx plus ay by plus az bz. So in order for us to know if the vectors are parallel, if they're perpendicular, the angle between the vectors is 21.4, we have to calculate for cosine of theta. So from these two equations here, we have to calculate for cosine of theta, which is going to be equal to, actually from this equation, cosine of theta equals to the dot product over the product of the magnitudes B. So let's go ahead and calculate A dot B using this formula here. A dot B is going to be equal to 3 times 4 plus 4 times minus 7 plus minus 8 times minus 2. Here I get that the dot product equals to 0. And this is actually very easy to respond now because we have had the previous example where we have studied what it means when the dot product equals to 0. But let's say we forget all that, and because we know when the angle between them is 90 degrees, right? That's when the dot product is 0. But let's just forget all that. I want to do a magnitude calculation. So I'll go ahead now and I'll calculate the magnitude of A. It's going to be equal to the square root of 3 squared plus 4 squared plus minus 8 squared. And this is going to be equal to square root of 9 plus 16 plus 64. And I get square root of 89. And then we're going to do magnitude of B. And just to point out, this formula is not given in the FE handbook. It's important for you to know the magnitude formula. So magnitude of B is going to be equal to 4 squared plus minus 7 squared plus minus 2 squared. And this is going to be equal to 16 plus 49 plus 4. And this equals to, we have square root of 69. Okay, so if we want to go back here, we're going to have that the cosine of theta is going to be equal to 0 over square root of 89 multiplied by square root of 69. So we're going to get that cosine of theta equals 0. This means that theta equals to arc cosine of 0. And we get that theta equals to 90 degrees. So this means that these two vectors are perpendicular. Answer is B. The problem number 4, what is the scalar projection of B on A? And remember when we looked at the FE information on vectors, they were telling us, I'm going to go back, they were telling us that the dot product represents the projection of B onto A times the magnitude of A. Let's see what that means. So let's assume I have vector B. Assume this is my vector A. And we are asked what is the scalar projection of B onto A. So in order to have a projection of B onto A, I'm going to draw a perpendicular line that goes to A. And this distance over here, I'm going to call it D. This is what we're asking to calculate. What is this distance over here? Of course, this in here is the angle between angle theta, the angle between the two vectors. So if I was to write again the formula A dot B, this will be equal magnitude of A times magnitude of B times cosine of theta. Now let's see here, if we apply the SOHCAHTOA cosine, because we have a right triangle, cosine of theta is going to be equal to adjacent over the hypotenusa. So we're going to get that cosine of theta equals to D over magnitude of B, the distance, right? And from this, we are getting that D is equal to magnitude of B cosine of theta. So we can easily calculate D, which is the projection of scalar projection of B onto A. So D, we have to calculate magnitude of B. It's going to be equal to square root of 2 squared plus minus 2 squared plus minus 1 squared. This equals to square root of 4 plus 4 plus 1. We're going to get square root of 9, which is equal to 3. And then we also need to calculate theta. How much is theta? We're going to go back to the formula of the dot product, which equals to magnitude of A. times magnitude of B times cosine of theta. So, and also we're going to use the formula for the dot product where we multiply the corresponding components. And this dot product is going to be equal to 2 times, or let me write the formula just so you get used to it. So we're going to have AX BX plus I'll write it down because I don't like it squeezed here. I don't like it squeezed here. Oh, from here, I will just go and take out the cosine, calculate for cosine of theta, which as we know, we've done this already. It's going to be equal to the dot product over the product of the magnitudes. So we have magnitude of B. I'm going to go ahead and calculate magnitude of A now, which is going to be equal to 3 squared plus minus 6 squared plus 2 squared. And I will get 9 square root of 9 plus 36 plus 4. And I will get square root of 49. So this is going to be equal to 7. So I have magnitude of A. I have magnitude of B. Now I have to calculate the dot product using the another formula that we also have for the dot product. And this is AX times BX plus AY times BY plus AZ times BZ. And this is going to equal to 3 times 2 plus minus 6 times minus 2 plus 2 times minus 1. And we are going to get that dot product equals to 6 plus 12 minus 2. I'm going to get 16. And now we can go back to the formula where we calculate for the cosine and substitute here. So we're going to have that the cosine of theta equals to 16 over 3 times 7. And I get 16 over 21. And this is equal to 0.76. This is equal to 0.76. So we know now that cosine of theta equals to 0.76. And now we can go back here to this formula and calculate for D. So now D is going to be equal to magnitude of B, which is 3, multiplied by cosine of theta, which is 0.76. And this means that I get D equals to 2.2829, which is approximately equal to 2.3. So D equals to 2.3 is the answer. The projection of B onto A equals to 2.3. And the correct answer is D.